Hello everyone, this is Sajal Devnath, and I'm writing this blog and recording this video after long. Earlier last year, I had written a blog post about auto scaling and how to create a POC, small POC for auto scaling using VMware solutions. I got a lot of questions regarding auto scaling and how we can configure the different things in using VMware solutions, and also I don't know, the workflow that I had shared earlier stopped working with vRealize Automation 7.3.1. So I have updated the workflow, and also I have reviewed the method through which you can send the notifications, and I have some modifications on that. So this blog post is really a deep dive into auto scaling. The questions that I got from customers, I have answered those questions here, and I explained a small demonstration using my lab. Sadly, I tried to record this video 4 times, and each and every time my video got deleted or something happened. So I hope this time it goes fine. So let's start. Uh, the agenda of this discussion, this is actually in two parts. The first part is 15-20 minutes on the presentation, which I talk about the theories of auto scaling, and the second part is hands-on labs where I show how to build the auto scale use case using various automation orchestrator and operations manager. So first part, the theory portion, I'm going to talk about definition. Why would you need autoscaling, the points to consider, the possible candidates, methods, examples, and final words. So let's start with the definition. This definition is from Wikipedia, and it says that the autoscaling can be spelled in different ways. Is a method used in cloud computing whereby the amount of computational resources in a server farm, typically measured in terms of the number of active servers, scales automatically based on the load on the firm. So it is very closely related to load balancing. So obviously the concept is, as your load comes, the servers active members in the server farm would scale as per your requirement. That only point that I want to make it here, uh, though Amazon started this feature in their AWS cloud offering, and then everyone else followed, including Azure and Google Cloud. But then I don't want to term autoscaling or associate autoscaling specifically with cloud computing, because you can safely build autoscaling capabilities into any virtualized environment, or for that matter in physical environment as well. Just think of it, you have high performance computing, probably that's one of the examples, but then you can have any database servers at 10 nodes in a database server, physical nodes, and at the runtime you add another node, you are actually scaling out, and then you remove another node, that is scaling in. So I don't want to associate the term specifically with cloud computing. I will try to define the feature, and then you can build it as per your requirement, any environment. Specifically with virtualized environment, it's very easy, and you can build it at any point of time. There are different types of auto scaling. Typically, scale up or down, though down is infrequently used, because if you scale up, meaning you increase the resources, CPU, increase CPU or memory as per your requirement. To scale down, you need to actually power off the server, so which you don't want in production environment. So down is very rarely used, but then most of the use case is scale out and scale in. Now, the question is, why would you like to utilize auto scaling, right? So, the first thing is, first and foremost, if you are running a private data center, it's going to save you tons of resources and electricity bills, energy and resources. The second thing is, if you're running it in cloud environment, running your environment runs on a public cloud, then it's going to cost you less, because the less resources you are utilizing in cloud, public cloud environment, the less bill you are going to get. The third point is, you don't have to make an upfront investment. Just for an example, typically, say for an example, I run a retail shop, and I know that down the lane I have something coming up, for example a Black Friday sale, that I know my website is going to get a lot of hits. So what I do in preparation, I deploy say 100 nodes in advance, uh, in anticipation of the load that I'm going to get. So I'm deploying servers which I'm not utilizing, and I'm paying for the resources. So with auto scaling, you don't have to do that kind of environment. Your servers will automatically get spinned out and then scaled in as and when the load increases or decreases. So it follows your requirement. And the other thing is, you can easily replace crashed or unhealthy nodes. Say, for example, you mentioned there's a requirement that at any point of time, the application that you run actually requires, say, 5 nodes to be present at all of the time. And now one of the nodes crashes, so automatically another node gets pinned up. That's how autoscaling would work. And by doing that, you would ensure that the uptime and performance criteria are always met. So these are a few of the benefits of using auto scaling in any environment, any form, right? And the reasons auto scaling is used primarily. The thing is, I have a lot of customers, a lot of uh, colleagues, a lot of people coming up to me and then say that I want to configure auto scaling. I just want to see the auto scaling, how it works and stuff. The thing is, there are a lot of consideration that needs to be given prior to applying auto scaling for any application, or implementing auto scaling in any environment. Specifically, there are two aspects. One thing is infrastructure, and another thing is application. Now, keep this in mind. Anything and everything to do is to do with the applications. Nobody bothers. The end users doesn't care about the infrastructure that I run. I mean, to be very honest, they don't really care about the application as well. Like, for example, as an end user, I really don't care what application or what web server you are running at the back end of the web page that I'm interacting with. All I care about is how my interaction is. So they all actually care about UI, but then application is the major thing which gives you that UI. So application is the major thing, and the next comes infrastructure. Now, scaling out and scaling in, or implementing auto scaling at the infrastructure layer, is very easy, especially with the virtualized environment. It's very easy to implement. But the thing is, the major consideration needs to be given to the application. The first thing is, the application needs to be auto scale aware. If the application is not auto scale aware, then it's of no use to you, right? And by the term autoscale aware, I mean to say that the application needs to be clustered so that it can support scaling out and scaling in the sense, at the runtime I can add nodes to it and then remove nodes from it as and when requires. That is what the application needs to be. If that application is not clustered, so I can give you 5 more instances using virtualization. It's very easy to deploy, so I can give you 5 more instances, but your main application actually does not recognizes those 5 more nodes. Doesn't make any difference to your end application, right? And the next thing that you need to think about is whether that application is stateless or stateful application, because depending on that, how it would react would differ. And I would talk about this a bit more in the coming slides. But then, just an example, that stateless application, like it can be your web servers with nothing stored in them. Now, that state can be of two types. To think of it, just to give an web server example, it's just an example that I'm giving, but then it's applicable to any application that interacts with the end user. The thing, there are two aspects of it. The first aspect is the data aspect, like whether if you are storing any data locally. If you're storing any data locally, that means that's a stateful application, because that server has certain information into it which is not stored at a runtime to any other location. So if that node goes down, it's going to impact your operation. That is stateful. And then the second thing is, I'm not storing anything locally into that server. So essentially, from infrastructure perspective or data perspective, that is stateless. But then think about it. Your end users are doing some kind of a transaction, say monetary transaction, using that application. And if the application or the connection breaks, that's going to create a problem. So that becomes a stateful server, because you cannot simply drop the connection that the end user has. So that becomes a stateful application then. Now, coming back to the consideration, there are a few considerations that you need to make. First thing is initial waiting period. The first decision is when to auto scale. It's not that the first moment you see a spike in CPU utilization, your CPU utilization goes beyond 80% for say 30 seconds and you start to scale out. It's not that. So you need to wait for certain time and you need to decide as per your environment, because that is a variable that depend. There is a lot of variable, lot of consideration, business consideration as well as technical consideration. So if you think that your application is such that you can wait for say 10 minutes of CPU utilization, say 80%, then you need to wait for that time and then do a scale out. And then next decision is the gap between scaling. You have scaled out the first instance. So for example, you had two instances running. You have scaled out one more instance, three instance, and then you need to wait and watch for CPU utilization to go beyond 80% in all three of them, and then you would scale out another node. So gap between scaling is also very important. You need to kind of decide that. Next is when to stop. What's the upper limit of scaling? Because thing is, no one has infinite resources, right? And God forbid, if your application comes under say DDoS attack, you cannot simply start scaling and consume all the resources. You cannot do that. So in any case, you need to decide on an upper limit, which you decide, say for example 50 nodes. I have an application which is a clustered application. I decide that the maximum number of nodes that can be in the cluster pool or server firm is 50. That's the decision that you need to make, that what is the limit that you are going to mm, give. The next decision is when to scale down. uh, I have say waited 30 minutes for my utilization to go below a certain point in all of the nodes, single node. You need to make that decision and then when to scale down. 30 minutes, 45 minutes, or 1 hour that you want to wait, and then you want to scale down. Till which point you want to scale down, that is also very important, because there are certain aspects. For example, there are applications you may decide that there can be a single node in that application and I would be running fine. But then under certain considerations you want to say, okay, I want all the time five nodes to be available for me in that cluster, so that if at any point of time any extra load comes, I should be able to handle that. So you keep five nodes handy. So in that case, you would scale down to five nodes and you would not scale down beyond that. So that's the point that you need to decide whether you want to scale down to one node or you want to keep something in buffer. And then the most important thing is triggers for scaling. What is going to be your trigger? A few examples: CPU memory usage, network traffic, like number of hits in your website, number of transactions, etc. But you need to absolutely decide on the triggers for scaling. Now, one thing is to consider as typical an observation is that when you scale out, the time taken for doing a scale out is typically less than the time taken to do a scale down. This is because you want to wait out longer so that you are sure that okay, I don't have any more load or traffic coming to my website. I can come down, because scaling out is a costly affair depending on what type of scaling you are doing. So you would always make extra headroom for scaling down. Now, another thing is coming back to that stateful and stateless. Now, while scaling down, you may decide that okay, while scaling out, I want to scale out using only CPU and memory usage. That is easy. CPU or memory utilization, you say CPU utilization goes beyond 70%, memory utilization goes beyond 90% for 10 minutes, you would go ahead and scale out. Now, if your application is stateless in both data perspective and connectivity perspective, then you can simply scale down after say 30 minutes if there is no load. That's fine. But then, if your application is stateful, just to give an example, your CPU and memory utilization has gone down, or has come down to 10%. So both the CPU utilization is 10%, memory utilization is 15%. But then there is one user that is connected to that server. You cannot drop that connection and then scale down. So you will have to wait for that connection to get over, and then you can scale down. So while scaling down, you have another consideration, another factor. So that's where it becomes very important whether your application is stateful or stateless, right? So you need to decide those functionalities, and you need to fine tune those parameters, because I keep saying this to everyone, and I keep hearing this from my customers, like what others are doing, and I get so frustrated. Each and every environment is different. You think about, okay, as a whole general approach perspective, you can ask that, but then you cannot really think that, okay, these guys are doing this, so I will do this as well. No, your application is different, your business requirements are different. So you need to decide that, okay, I'm going to select these factors, and then I'm going to fine tune based on my requirement. And then the thing is, you need to decide that I'm not going to do a scale out. Pretty much. I don't want to be in that situation that I'm all the time, I'm just doing scaling out and scaling in. It's going to put a lot of unnecessary pressure on your environment. Possible candidates: stateless web server. They are very good, very good candidates. Stateful front end servers. You can It can be a web server, it can be your homegrown application, anything. Mid-tier application servers. It can be database server as well. Typically, with database servers, we don't want to scale out that much. We want to scale up probably, and then scale out if you want multiple nodes. But then I say that. Um, it's always limited by your imagination. You let me know what are the possible use cases that you are thinking, and then that would be amazing to know something, some amazing use case, right? Now, methods. What methods we can follow to do a scale out, or says auto scale? So there are typical two methods that are followed in any production environment. One is pre-deployment, and another one is runtime deployment. Both have their positive negatives, and we are going to talk about that. The pre-deployment method, as the name suggests, what you do, you pre-deploy the maximum number of nodes that you have decided that it's going to be in your cluster. So if you decide to have 50 nodes in the application cluster at server firm, so you deploy 50 nodes in a single shot, and then you decide, okay, for my regular operation I only need 5 nodes, right? So keep those 5 nodes on, and then shut down or keep rest of the 45 nodes in standby mode. That's what you do. And then when the load comes, you power them on and just bring them into operation. That's the pre-deployment method. The advantage is very less reaction time, probably the least reaction time. The moment your load comes, or depending on the scale out decision time, after say, I will just take a fixed value for each and every example, say 10 minutes. You decide that after 10 minutes of load, I'm going to scale out. So after 10 minutes, it's just within few minutes, say probably within less than 15 minutes total, from start to end, you would get a new server, right? Uh, the another advantage is at the runtime, it does not require resource intensive operation. Uh, for example, if you want to deploy a new node, it requires a lot of writing to storage, so a lot of storage IOPS, and the lesser storage IOPS that you would get from infrastructure side is better, because as I said, your infrastructure is there only because of the application. So in any environment, in ideal case, I'd like to get all the IOPS from application only, not much IOPS for purely from infrastructure perspective. You should try to maintain your infrastructure's IOPS to a minimum. All the writes reads should happen from the application side. It's an ideal condition. It never happens, but then that's the target that you should have, right? So that is one of the advantages. The disadvantage is it does not give maximum saving, because though your servers are powered off, you are not consuming CPU memory, but then still you are consuming storage. right? The second option is runtime deployment, and as the name suggests, the nodes are deployed at runtime. So as the nodes are deployed, they become part of the cluster, or you can say node addition or removal, or you can configure all the nodes pre-decided node that okay, my cluster will go till 50 and then it will not go beyond that. So the nodes are deployed and they are automatically part of the cluster, or they can join the cluster at the runtime. The advantages are this, which this is anyways going to give you the maximum resource saving, because anything and everything is deployed at the runtime. It's going to give you the monetary best monetary saving as well. Now think of the disadvantages. It's going to take large reaction time. And just think of it. Say you decide that 10 minutes is my triggering point. So after 10 minutes the machine is actually getting deployed. If you are cloning from template, still it's going to take few minutes powering on, then adding it to the cluster. It's going to take some time. So it takes 10 more minutes. So you get total 20 minutes. After the triggering happens, you say after your load hits, after 20 minutes you get a server. But the question is, the first 10 minutes is constant in any aspect, but the next 10 minutes, the when the actual deployment happens, it is variable. You can never surely say, you can get an average, but you cannot say it's going to get between this time or exactly at this time it's going to get deployed, because your deployment of actual deployment and powering on everything depends on the underlying infrastructure. Now, most of the cases, you would have enough resources, and in public cloud environment as well, typically you would have all the resources. But then, things happen. If for some reason your entire infrastructure is under a lot of stress, it's going to take much longer to deploy that virtual machine. So that latter 10 minutes is going to be variable. You cannot be sure that within 20 minutes your server would be up and running, the new server. You can never be sure. So that's the disadvantage. The other disadvantage is, well, it's getting deployed, you are incurring that extra storage IOPS, which is purely infrastructure. You are just deploying a machine which is going to ultimately support your application. It's not application data IOPS, it's your infrastructure IOPS, right? So that's the disadvantage. But now you need to choose between these two, because the pre-deployment method is best for business because your reaction time is the least. But then the run deployment time, it's going the pre-deployment time is going to take uh, more money as well. So it's a fine balance between your requirement and the saving, like technical requirement and the saving. You need to decide and find that middle spot, which works best for you, right? It's just to say that probably one or two application would be such critical, of such criticality that you would like to make it pre-deployment method, because you cannot wait for the time to get the full machine deployed. So in that case, those machines should go into probably be suited for pre-deployment method. But then majority of the auto skills applications would be runtime deployment, right? Now auto scaling in my environment, as I said, I'm thankful to VMware. I work for them, and I get all the software that I need. So in my lab, I run only the VMware softwares. I have vRelease automation, vSphere as an endpoint, NSX, and VRO is my automation, say, orchestrator engine. So the end users deploy machines through vRelease automation. It utilizes vCenter NSX, and then I utilize vRealize operations as monitoring solution that is going to trigger my alerts. It's going to monitor my environment. It's going to tell me, okay, this is where your utilization is this much, and you should act upon it. So it's going to send out the trigger to VRO, vRealize orchestrator. vRealize orchestrator in turn going to talk to vRealize automation and say, hey, scale out, or if required, scale in. So this is my lab setup. And now, uh, coming to this, there are three ways I can send an alert notification from vRelay's operations manager to VRO, vRelay's orchestrator. They are SNMP traps, uh, REST notification, and VRO plugins for vRelay's operations manager. Now, in my earlier post, I had detailed about SNMP traps. They are the easiest one probably to set up, but then it's the least preferred method, I would say. REST notification would need need you to deploy a third party product, or say a third component into it, and then via a plugin I'm going to talk about in detail when I'm going to do a demonstration. But then I would prefer a VRO plugin over anything else, because that is from a VMware supported, and it's the future that I see. Now, if you want to utilize REST notification, uh, though it's JSON format, the data that's passed, but then the format in which vRelay's operations manager sends the alert is not understood by vRelay's orchestrator. The format is different, so you need something in between as a translator. Webhook Shims does that translation for you. So it just translates the data and sends it to VRO. VRO then submits a job back to VRL's automation using API, and VRL's automation creates the VM in the endpoint. So that's the entire webhook shims, the requirement and the REST API and the REST notification setup. The steps from the operations manager perspective, you need to configure the outbound settings if you are doing SNMP or utilizing SNMP or REST notification. If you are utilizing VRO plugin, you don't need that. You need to configure symptoms in VROPS, then alert definition, and then configure notification. In Orchestrator, import the package. I have given the package link in my blog, and then you need to configure the workflows, configure the trap receiving mechanism if you are utilizing SNMP. And I'm not going to talk about SNMP much, because if you want to utilize SNMP, please check my earlier post. It has a detailed portion on SNMP. For REST notification, you need to configure webhook shims and then configure workflows to handle the REST notification. As mentioned, I would not like to utilize webhook shims at this moment, because I have a third component. So I don't, in my solution, I don't want to, or say I want to minimize the number of components that I put, because in a car or any machine for that matter, if you, the more components that you put, that means there are more possible uh, points where it can break, right? So that's the reason I would like to utilize vRealize orchestrator plugin for vRealize operations manager, um, for from going forward. For VR plugin method, I'm going to talk in detail in the video. When I do the demonstration, I will tell you exactly how it's done, and then I would show you the details of that. So, final words before I move on to demonstration. As I always say, don't do it simply because you can. With great power comes great responsibility. I love this dialogue from you know Spider-Man movies. It's actually very true. You cannot, or not every application is meant for auto scaling. Probably if you have 100 applications, only 10% or less would be well suited for auto scaling. So you need to decide which application you are going to select for auto scaling, right? And then design properly those decision points, the considerations you need to make. Those are really very crucial for proper operation. You don't want any surprises in the production environment, though you would keep tweaking it, but then there shouldn't be any surprises. So design properly, decide the triggers wisely. As I said, like when you are scaling out, you can only decide on CPU and memory, but then when scaling in, a few more variables come into place depending on the state of the application, right? And similar, it goes on for your environment. It may be a few more variables as well. And then take a step by step approach. Don't try to configure the whole thing at a single go. Take a step by step. First, set up the auto scaling where you are scaling at the infrastructure level. Then set out the application scaling, and then fine tune that environment before you take it to the production. So those are the suggestions that I can give, right? And at last, I want to really thank VMware for the PowerPoint template that I have here. This is the absolute amazing PowerPoint template. Okay, next I would go to the second phase where I would showcase my demonstration, showcase my lab environment where I would show uh, small POC examples.